Welcome students. Let us look at the topic of tangents to a circle. We know what a tangent is. A tangent is a line which touches the curve at only one point, right? Now let us take the circle x square plus y square is equal to r square. Now, how does a tangent to the circle look like? We try to analyze three different forms of the equations of tangents. The first is the slope form. The second is point form. Third is parametric form. We see these three forms of the equations of tangents. First, the slope form means if you are given the slope of the tangent. For example, you are given x square plus y square is equal to r square. I want a tangent of slope m. So if y is equal to mx plus c is a tangent to the circle, what will be the value of c? So we have already done this in our previous video. We have found that c is equal to plus or minus r root 1 plus m square. So y is equal to mx plus minus r root 1 plus m square is the slope form of tangent to this circle. And if you substitute the value of m and the value of r, you already got the circle. You'll be given a circle, so you know the value of r. You'll be asked to find a tangent of particular slope m. So you just need to put m here and r, you get the equation of the tangent. For example, if you want x square plus y square is equal to 36, if you have the circle, you want a tangent of slope m is equal to 3. You want tangents of slope 3. So what are the equations? Just y is equal to 3x. Just put m is equal to 3 plus minus r is given to you because the circle is given, r is given 6 root of 1 plus 3 square, that is 9. This implies y is equal to 3x plus or minus 6 root 10. So this will be the equation of the tangent whose slope is m is equal to 3. You have two tangents. So correspond to each slope, you have two tangents to the circle, one on this side and the other on that side. Next, let us go to the point form of circle, point form of tangent. That is, if you have a point P, x1, y1 on this circle, what is the equation of tangent at this point? So if you are asked a question like that, for example, you have x square plus y square is equal to 25. If this is the circle, what is the tangent at the point 3, 4 on the circle? So you will be given a point on the circle. As you can see, 3 square plus 4 square is 25. 3, 4 lies on the circle. Now what is the tangent at this point x1, y1 on the circle? So how do we find this? If you know the slope, it is very easy to find. But here you are given the point. From the point, you can find the slope of tangent at that point, and then we can go forward. So how do we find the slope of tangent to this curve at this point? By differentiation. So you'll get this topic in your 12th class, but for now just accept that the value of differentiation of the curve at this point represents the slope of the tangent. So if you have the curve x square plus y square is equal to r square, you want the slope of tangent at the point x1, y1, just need to differentiate this. 2x plus 2y y dash, which is dy by dx, is equal to differentiation of r square. R is a constant, so it is equal to 0. So this implies dy by dx is equal to minus x by y. At a general point x comma y, dy by dx is minus x by y. So what is dy by dx at the point x1 y1? Is nothing but minus x1 by y1. Minus of x1 by y1. Now, you know the slope, you know the point. So what is the equation of tangent? You know the point, you know the slope. So equation is nothing but y minus y1 is equal to slope minus x1 by y1 times x minus x1. So if you simplify this, if you do the cross multiplication, y1 minus y1 square is equal to minus xx1 plus x1 square. This implies xx1 plus y1 is equal to x1 square plus y1 square. x1 square plus y1 square, because x1 y1 is a point on the circle, x1 square plus y1 square will be equal to r square. So what is the effective equation? xx1 plus y1 minus r square is equal to 0. xx1 plus y1 minus r square is equal to 0. So does this equation look familiar to you? The equation of the curve is x square plus y square minus r square is equal to 0. If you take this as s, what does this expression be? X square is replaced by xx1, y square is replaced by y1. So this is nothing but t is equal to 0. So if you want a tangent at a point x1 y1 on the circle, you just need to write t is equal to 0 correspond to this point. So the point form of tangent is t is equal to 0. So what is the equation of tangent to this curve at this point? Just x square is replaced by xx1, that is 3x. Y square is replaced by y1, that is 4y. So the equation of tangent will be 3x plus 4y is equal to 25. As simple as that. The slope form is y is equal to mx plus r minus r root 1 plus m square. Point form is t is equal to 0. Now let us go to the parametric form of the equation of tangent. Parametric form means that the point, instead of giving you the x coordinate and y coordinate, will be given the parameter theta of this point. We have already seen what the parameter is. Parameter is nothing but the angle made by this ray with the positive direction of x-axis. So if theta is given, what is the equation of tangent at that point? Obviously, if theta is given, the point corresponds to r cos theta comma r sin theta, right? This is what we have seen. R cos theta comma r sin theta. So you got the coordinates. You just need to substitute x1 and y1. So x times r cos theta plus y times r sin theta is equal to r square. 1 r will get cancelled. So what is the parametric equation of tangent to a circle? X cos theta plus y sin theta is equal to r. So these are the three forms of tangents to a circle. Y is equal to mx plus r minus r root 1 plus m square. T is equal to 0. X cos theta plus y sin theta is equal to r. Please remember, the equations that we have derived for now work only for the equation x square plus y square is equal to r square. We are dealing with the simple equation of circle. If the equation becomes complicated, How we need to change these forms will be discussed later. For now, for x square plus y square is equal to r square, the slope form is this, the point form is t equal to 0, parametric form is x cos theta plus y sin theta is equal to